Good afternoon, everyone. It is once again Ted the Speed Learner. Today is my birthday, but I'm giving you guys the present. And what is that present? Well, this is a Bezier curve update. And the reason I'm doing this is because we are literally one step away from solving the problem of the Bezier curve and ultimately drawing the Bezier curve in SVG. And when we can do this, we can then draw animations, we can do all kinds of stuff, and we can post this kind of information on YouTube or the pictures, whatever. And that literally boosts our ratings. It will also give you guys the ability to make thumbnails out of SVG, which could boost your ratings on YouTube. Okay, so how are we going to do this? Okay. The first thing we're going to do is draw this triangle right here. Okay, we're going to draw this on the Cartesian coordinate system. Okay. Now, I have covered the Cartesian coordinate system in my mathematics videos, so you can check all that out for yourself. Go to the mathematics playlist. You can look that up for yourself. You can look this up on the internet if you'd like. Alright, but let's go through this. Alright, we're going to have 3 points on this triangle. We have to have these 3 points to draw the Bezier curve, and I'll show you why in just a minute. Okay, so we have P1 here, P2 here, and P3 right here. Now, as you notice, all 3 of them have X and Y coordinates. Now, I've already discussed this in previous videos. Okay? Now, let's say that the X coordinate of P1 is 150. So, what we did was we drew this picture out on some graph paper, and we said that at pixel 150 we're going to draw the P1 coordinate. Okay? Now, this is a mistake. We've already made one mistake here. This should be P2, and this should be P3. Let me fix that. This should be P2, and this should be P3. And there is a reason for this, okay? This is point 1, this is point 2, and this is point 3. All of these little numbers here, I know they don't look like subscripts, but that's what they are, okay? Now, if you'll remember from previous videos where I discussed superscripts and subscripts, you'll know how important this is. By the way, I'm hoping that Crazy Josh Cravey and D. Lukens 9 is watching this particular video because they could really help me out with this. Okay, let's go on. Alright, so we have point 1, point 2, point 3. That's what we have. Okay. Now we're going to say that the X coordinate of point 3 is 450. Okay. Now, what we want to do to find the X coordinate of point number 2 here, okay, this point right here, what we're going to do is we're going to take the 450 and we're going to subtract the 150, and when we do, we get 300. Okay? Now, the 300 is how many pixels there are between 150 and 450. That's what that 300 actually is. Okay, so there are 300 pixels between here and here. Okay, now let me make sure you're seeing all this. So far, so good. Well, that's good. Okay. Now, we're not looking for the number of pixels between here and here. We're looking for this point right here. This is the midpoint. Now, the midpoint is a point on this line that is halfway between point 1 here and point 3 there. That's what we're looking for. We're specifically looking for the X coordinate of this. Now, we said the X coordinate of this point is 150. The X coordinate of this point is 450. We said that there are 300 pixels between those two. What happens when you divide the 300? Well, and make sure you see the 300 up there. Very good. Just making sure you see everything. What we're going to do is we're going to divide this number by 2. Okay, that makes 150. Now this 150 would be all great and grand and dandy and whatever you want to call it, except that our line doesn't start at 0. Our line starts at 150 and ends at 450. So what we have to do is we have to add that 150 to that 150 to get the x-coordinate, which is 300. Okay? So 300 is the pixel point between 150 and 450. Now guess what? That 300 there is the actual x-coordinate of this. Because we can draw a perpendicular line between that 300 and point 2. And when we draw that perpendicular line, we have 300. Now, this also tells us one other thing. That when we go through the Bezier curve equation, the quadratic Bezier curve equation, when we get to the midpoint of it, that coordinate right there is going to have an x-coordinate of 300. So not only have we discovered that 300 is the midpoint of this, but we've also discovered that 300 is also the x-coordinate of P2, and it's also the midpoint of this curve. Neat, huh? Alright, now, here's the thing. If you add anything to that 300, this curve is going to curve to the right. Okay, so instead of it being straightforward like this, it would be more like that. Okay, so it'd be kind of like a mountain leaning on its side, like the Leaning Tower of Pisa. Okay, now, let's say that we subtract from the 300. If you subtract from the 300, the curve is going to lean to the left. The more you subtract, the more the curve is going to lean this way. The more you add, the more the curve is going to lean that way. So, that's why you have to have the x-coordinate. But why do you have to have the y-coordinate? Well, I'll tell you the reason why. Because, do you want a tiny hill, or do you want a great big mountain? The higher up this point is on the y-axis, the bigger this curve is going to be. It's going to look like a mountain. The lower this y-coordinate is, the more flat this curve is going to look. In other words, it's going to look like a little hill instead of a great big mountain. That's why you have to have the y-coordinate. Okay, so how are we going to get this y-coordinate? Well, I have an idea about this, but I'm going to need some assistance. This is where you guys come in. Alright, I think you can clearly see that what you have here, once you draw this midpoint line, this perpendicular midpoint line, guess what? You're going to have two 90-degree triangles automatically. Okay? Now then, let's say we knew all three of the, the number of degrees in this angle is 90. Okay, and let's say we knew the number of degrees of this angle and this one as well. Then we can start using trigonometric ratios because we already know the length of this line, which is, there are 150 pixels between here and here. So you already know the length of this line right here, and if we know all three of these angles, we can use sine, cosine, and tangent to not only figure out the length of this perpendicular line, but also the length of this line, the hypotenuse. And when we do that, we can actually figure out at what point these two lines are going to intersect. We need to know this to find out the y-coordinate. So, if you guys can come up with a formula to help me out with this, we can find that y-coordinate and do this right. Now you say, well, wait a minute. What would happen if instead of the triangle being straight up like this, let's suppose let's erase all that. Let's suppose, like with a horse's nose, okay, when you're drawing a horse, a Clydesdale horse, okay, his nose is not going to stick up straight up in the air. That'd be virtually impossible for a horse, okay? So let's say the horse is like this, okay, that's his nose. Let's say we have ears like this, and we could draw the whole body of the horse, you know. I know this is a really bad looking horse here, but let's say the nose here is pointing down. Okay, we'll draw a little eye here. But this is the horse's mouth. We'll have a little drawn nose here, and we'll draw a little mouth like that. And that, I know that's a really horrible looking horse here. Okay, but I'm trying to illustrate a point here. What if it's drawn like this? Well, you can actually draw a diagonal like this. Okay? You could then find the midpoint. You could then draw a perpendicular line. Okay? But we need equations to find the midpoint of this line, so we can then use it for one of the two coordinates, and then we just have to find the perpendicular here and determine the other coordinate. And that's how that would work. Are you seeing where I'm going with this? Okay, now then, I'm going to hold this board up for just a minute. I want you to copy this equation that I'm going to hold up. I need you to do this because I've got some things to explain to you. Now take a look at that equation. Let me make sure you guys are seeing this properly. No, you're not. Alright, I'm going to try this a little bit better. And boy, this is not going so well. Okay, let me just set it right here. How about that? That's perfect. Alright, now I'm going to zoom in just a bit. Can you see the equation now? I think you can. Okay. Now, why do you have to have this equation? Because what you're going to do is, and I've really got this written down poorly. Let me change the P. Let me change these right here. Okay, let me change these to 1, 2, and 3. As you can see here, all three of these are subscripts. Now, what is P1? Well, we're going to put the x-coordinate of P1 right here. Okay, let me go ahead and do this. And we're also going to put the x-coordinate of P3 right down here. See that? Let me make sure you're seeing this. Very good. So we got 150. So what you would do here is you would erase the P1 and replace it with 150. You'd erase the P3 here and you'd place 450. Now you say, well, what about P2? Well, we know that one as well. We know that this is now going to be 300. So you'd erase the P2 and you put 300. Now what's the value of T? Well, the value of T goes from 0 to 1. Okay? So what you do is you'd have 0.10, 0.20, 0.30, and so on and so forth, all the way to 1 point. Now the thing is that if you're using SVG, okay, you're going to put the x and y coordinates of P1 into it. You're going to do the same thing with P2 and with P3 as well. When you do, the computer is automatically going to calculate all of these points here based on what you put in with the P1, the P2, and the P3. That's what it's going to do. Do you see what I mean? Okay. So what you're going to do is you're going to throw in various values for t. Now, the computer will automatically do this equation for you if you're using SVG. But if you're not, you're trying to do this manually, that's okay. What you're going to do is you're going to throw in various values for t, and you're going to go all the way through, and that's how you're going to find the answer for this. And what this is right here, when you do all this, is this will become, the one I just circled here, will become the x-coordinate for this line. And as you go up from 0.10, 0.20, 0.30, 0.40, 0.50, okay, so let's say you had a 0.5. Let's say that P is actually 0.5 instead of T. Let's say we change the P of T to P of 0.5. Then you replace all these T's with 0.5. Then you start getting the x-coordinate. You'll get the x-coordinate of 300. That's what you'll get. Let me say that again. If you replace all these T's with 0.5, and you replace the P1, the P2, and the P3 with all these numbers here, you will get 300. That's what you're going to get. Okay, now you see how this is working? Now you say, well, okay, that's how we get the x-coordinate, but then we use this equation again, and what we're going to do is we're going to replace all of these with whatever we figure is the y-coordinate. So this will be the y-coordinate P1, P2, and P3 as well. You see how this is working? And that's how you're going to plot the points of this Bezier curved line. So all we're missing here is the y-coordinate of P2. And if you can figure out some equation that will give me the y-coordinate of P2, I can finish my presentation on Bezier curves. So D. Lucas 9, Crazy Josh Cravey, if you guys can figure out a way to get that y-coordinate, you let me know. Because I'd like to finish this up, and I'd like to draw this horsey in SVG in the proper way. And not draw some ugly horse like this. I don't think you want me to draw an ugly horse. Alright, so now I've given you half of the solution. I want to thank you very much for watching this presentation. I know this is my birthday and all, but I wanted to give the biggest present to all of you. And I think this is a pretty good present, don't you think? Alright. Well, again, I'd like to thank you for watching this presentation. Crazy Josh Cravey, a final note to you. I have not ignored your entries into the video response wars. I will be working on that. I promise you. Alright. So, I want to thank you guys very much for watching this presentation. You guys all have a wonderful day, and I will certainly have a wonderful day with my birthday. I will tell you more in a future video, so I'd like for you to stay tuned.